Okay guys, so today we're gonna do the a problem that I find it's awesome. Let me just look it up. Diameter of a binary tree. So if you guys have seen my last video, I participated in the Lit Code contest. I got my ass kicked and one of the problems was pretty similar to this one. So first I'm gonna solve this one today and then I'm gonna solve the one on the contest tomorrow, because the one tomorrow builds upon this one, and this one builds upon the video I did called max depth, because it's something kind of similar. I'm gonna try to speak faster because I saw my videos afterwards and I speak pretty slow. If you think I speak slow, change the time of the videos to 1.25 or 1.5 is much better. But let's do it. So given a binary tree, you need to compute the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the roots. So, for example, in this tree, you return 3, which is the length of the path. 4213 and 5213, one of those. So the diameter of the tree is the longest path. So if you start here and you go here, you have 4 numbers, but you have 4 edges. So this connection between two numbers is called an edge between two nodes. And so there is a very important, so obviously, as I always mention, trees, you should start thinking recursion. Start thinking recursion right away. And now we have to understand how to make the recursion call. So we're gonna have to get the max length and kind of updated it at each iteration, because not all of the longest paths will go through the root. They might be like here or somewhere like here. So we have to like count the longest path for a certain node, for example 4, and compare it to all the nodes in the tree. And for that, we're gonna use a class variable. So the class variable will be the one that will always be updating as we go down the tree. So we keep track if if it's the longest path. This was a really cool trick I learned through this problem, which is creating a variable that will keep track of something in a recursion. I didn't know that, so I hope you guys learn this trick as well. Another thing I want to mention is that the longest path will be the sum. So this is the most important thing. The longest path will be the sum of the height from the left node plus the height from the right node. So I'll give you an example. So we're at node 1. What is the height of the left side of the tree? So the height is 1, 2, 2, right? So you have this level here and this level here. You have 2 levels. So this is the height of the left side of the tree. What about the right side of the tree? It's 1. So the longest path is the sum of 2 plus 1. So this is important. Every iteration we're going to calculate the depth of the left side of the tree, the right side of the tree, sum them together and compare with the global variable, the class variable. If it's larger than the class variable, we replace the class variable by that number. It's gonna be clear as I code. So first, let's create a variable called longest. This is the class variable that will keep track of the longest path, and we're gonna declare another function called depth, and we're gonna first So this is where we're gonna do the recursion. First we're gonna do the base case. Usually in a tree the base case is if root equals none, return 0. So the longest path of a none tree is just 0. Now we do the recursion call. So we're gonna do depth root.left, and we're gonna assign it to a left tree and right tree depth root.right. So what I'm doing here with this left tree, right tree, actually I'm gonna call left height tree, so it's clear what I'm doing here. So left height tree is calculating the height of the left side of the tree, and it's gonna do that for every single node. You're gonna calculate the height from the left side and from the right side, from the left side and from the right side. Then we're gonna return. Then we're gonna see. This is the really cool trick. We're gonna see if the sum of the left plus the sum of the right is greater than the longest. So for example, if I'm at 1, the longest here is 2, right? Because I have 1 and 2. Let's suppose this is the best, and then I go up the stack on the recursion call and I go to the root. So it's gonna compare 2 with 3, which is the longest path at 1. And then longest will be updated to 3. So longest will keep track of the, forever iteration will keep track of the longest path through the tree. The longest path through the tree. And then we return the depth, which is depth. It's max of the left height tree. So this is standard. This is what we did in another, oh, this is right. This is what we did in one of the first videos, if I'm not mistaken. So nothing new here. We're just calculating. If you don't understand this part of calculating the depth, just look at my previous videos where I explain max depth. So these 2 lines, all of these are exactly like max depth. The only thing that is different here is the longest. And the longest is the sum of the left height plus the right height, and you update every iteration to see if this sum is greater than longest. And then, so here we're gonna call the depth function with root, and then we return the result of longest. Let's submit it. Taking a long time. Is there a mistake? No. So yeah, so the 2 cool tricks that we haven't covered is the class variable that will update, and knowing that the longest path is the sum of the left height and the right height. And we're gonna use those 2 concepts in the video tomorrow. So I hope you guys enjoy it, and see you tomorrow. Subscribe to the channel and give your thumbs ups as well. And put the speed at 1.5 if I'm slow.